Hi viewers, welcome to LMS Solution. Today we are going to see about MATLAB simulation of PSO-Trained ANFIS MPPT for solar PV system. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. So I'm going to open that structure of ANFIS. So this is structure of ANFIS, that means Adaptive Neuro-Fuzzy Inference System. So the system having 5 layer, right? ANFIS having 5 layer, layer 1, layer 2, layer 3, layer 4, and layer 5. Okay. In this ANFIS, the layer 1 and the layer 4 known as that means in layer 1 you have to distribute that input with the membership function, and layer 4 you have to do some calculation by using this formula. That means f1 equal to p1 x1 plus q1 y r1. Okay. So this layer 1, layer 4 are known as a tunable layer, right? That means it have some tunable parameter. So layer 1 are known as membership function. For example, you consider you are using Gauss membership function for two inputs x and y, right? So then we need to tune. We get two parameter to tune in the Gauss membership function. Nothing but center of that Gauss membership function and the standard deviation. Okay, that two parameter known as the tunable parameter in the Gaussian membership function. And same way you can see that in layer 4 you have to use that formula and to calculate that f1, f2, f3 and so on to fn. Okay, so in this equation you can see that the three parameters p1, q1 or r1 known as a tunable parameter. Okay, so these are the tunable parameter in the adaptive Neuro-Fuzzy inference system. So normally this parameter can be tuned by means of hybrid algorithm known as back propagation algorithm as well as least square method. Okay, so instead of using that back propagation algorithm and that means least square optimization, so you have to use here I'm going to use particle sum optimization to tune the parameter of that membership function in the layer 1 and then parameter in the layer 4. Okay, for example, I'm going to consider causing membership function and I'm going to tune that parameter of center and standard deviation of that Gaussian membership function by using PSO, as well as in layer 4 I'm going to tune the parameter of parameter P, Q and R in the layer 4 in the ANFIS. So by using the PSO I'm going to tune that ANFIS network in order to get the perfect model. Okay, the same concept going to be applied for the maximum power point tracking algorithm. So let's start with the simulation. So here you can see that we already created different program for train that ANFIS with the PSO. So here first I am going to open this model. This is a program used for generating the data. So by using this program, we are going to generate the input and output data for that ANFIS. So PSO-Trained ANFIS network. That means that ANFIS is going to be modeled with that. That means ANFIS is going to be act as a equivalent solar PV model. So that means the input going to be considered as two parameters. One is temperature. So another one is irradiation. So these two parameter considered to be a input parameter, input data for that PSO-Trained ANFIS network. And then I'm going to consider the output parameter. Our target data for the ANFIS network is known as VMP. That means the voltage at maximum power point. So this is going to be considered as the output data, target data for that ANFIS network. So this is going to be collected by means of this program. So here we are going to collect the 1000 samples. Okay. So after that collecting the data, I'm going to store the data in the file pvdata.mat, right? So this data, after that this data going to be used in the training process. Okay, so in order to execute the training process, So we have another program. So this is the uh, training program for ANFIS by using PSO. Okay, so here first we need to load the data. So this command used for load the data, and then this command used for generating the initial fuzzy inference system by means of fuzzy C means clustering. So after that, this command used for train the ANFIS network by using PSO. So finally, we will get the trainings details here. So after completing of the training process, the final detail will be can be plotted by means of these details. Okay, that mean the plot relevance to the training data and plot relevance to the test data. Okay, so next I'm going to open that how we are creating that initial MPPT function. So this is a program used for generating that initial fuzzy inference system by means of fuzzy Siemens cluster. Okay, and then here you can see that this is the program for loading the data. So this data can be collected from that this program, right? PV model program. So from that PV data, so you have to segregate. That means you have to separate into input data and target data, and then the data going to be used for train the ANFIS network. Okay, so next after that we go for in that I'm going for training anfis-pso. So this is the main program used to for that PSO, particles from optimization. Okay, so in here you need to provide that parameter. Okay, so we need to provide a parameter. That means which parameter we have to tune in that ANFIS. Okay, so for that you have to write this code. So this code used to for getting the parameter of the adaptive Neuro-Fuzzy Inference System, and then this code used to for getting the objective function or cost function. Okay, that mean during execution of this function, what will be happen? That mean after training, after every training, right, every iteration, that the trained data going to be compared with the target, and then you have to calculate the root mean square error value, right? That means the root mean square error going to be considered as a cost function. So the objective in this PSO-trained ANFIS, you have to minimize that root mean square error, right? Not to train the ANFIS with the input output data. Okay, so and then you have to provide the number of variables by means of that uh, number of parameters getting from that ANFIS initial fuzzy inference system, and then you have to provide the number of population, number of iteration. Okay, so everything you have to provide here. So and then we have to execute the PSO in order to train the. So this run PSO is to for executing that particle form optimization to train that ANFIS. Okay, so here we have to call that cost function number of variable, and then variable minimum and maximum value, right? And then maximum number of iteration, number of population, and then C1, C1, C2, W, right? So this is a program for the two particles from optimization. So here we are going to updating the velocity of that PSO. So by using that PSO equation, okay. So that every iteration it will be trained that ANFIS network based upon that input and output. It going to be tuned that parameter of that ANFIS, right? The parameter of input membership function and parameter of layer 4, that means P, Q, and R. Okay. So after completing all iteration, so finally it generate the fuzzy inference system, that means trained adaptive neuro-fuzzy inference system for MPPT algorithm. Okay. So next I'm going to open that cost function. So this is a program used for calculating cost function. That means here we are going to calculate the root mean square error, right? So you have to, that means we need to minimize the root mean square error That means here you have to calculate error target minus y. So t nothing but target, y nothing but r. After every iteration, the ANF is going to be trained with some parameter. So this output of that ANFIS network. Okay. So it's going to be combined with the target, and then we calculate the error. So after 3 we have to calculate root mean square error. So that should be minimized by means of the particle sum optimization with every iteration. Okay. So after completing that all iteration, finally we'll get a fuzzy inference system in the workspace. So that should be stored in the file. So that file can be used for implementing that MPPT algorithm. Okay, in the Simulink model. Okay, so first I'm going to simulate this one. So here you can see that the iteration process will be started. So every iteration you can see the variation of the cost, reduction of cost, right, by means of the PSO. So after completing iteration 1000, the final result will be stored here in the workspace. Right, iteration is completed. So here you can see this is a plot between train data and test data. So here you can see that the root mean square error is around 4.471 into 10 power minus 15 for the training data. So for testing data, the error is around 5.64 into 10 power minus 15. Okay, so error, the root mean square error value is very less by using that PSO particle sum optimization. So next you can see that here. Okay, so here the finally trained data, that means final trained adaptive neuro-fuzzy inference system file will be available here in the FIS format, right? So just you go to type now fuzzy and enter. After that, open the file by using import from workspace. Okay, so here you can type the file name is FIS, right? The file name is FIS, right? Just you go to open this one. So you will get the trained data here. Okay, so this is a trained data for given inputs. Okay, given input output data. So next, so you can store this data in the file. So for that, go to export to file and then say with your file name. That means already I stored as a PSO.FAS. So you can save with the different names. Okay. Or else I'm going to save this file PSO1.FIS, and then we got to use the same file for implementing that MPPT and this MPPT. Okay, so and then close this file. So next already we developed some Simulink model for implementing that ANFIS MPPT. So I will open that file. Yeah. So this is a Simulink model developed for that PSO-Trained ANFIS MPPT. Okay. So it consists of solar panel. So here we are using 250 watts PV panel. So I'm going to open the parameter of that PV panel. That means block parameter. So here we are using one parallel string and one series string. So this is a rating of the PV panel. So it's maximum power is 250 watts at the standard test condition. That means 1000 watts per meter square and 25 degrees Celsius. So this is open circuit of this model 37.3, and then voltage in maximum power point is 30.7, and then short circuit current of this panel is 8.66 amps, and then current in maximum power point is 8.15. And also I'm going to plot that IV and PV characteristics of the consider PV panel. Okay, so this is a corresponding IV and PV characteristics of the consider PV panel. Okay, so here you can see that maximum power point for different irradiation. So this is 250 watts, right? So 250.2 watts when the radiation is 1000 watts per meter square and the voltage is 30.7. For 800 watts per meter square, the maximum power is around 199.9 and the voltage will be 30.68. For 600, so maximum power is 149.6 watts and the voltage is 30.62. And 400, the maximum power is 98.97 and the voltage is 30.47. Okay, so same way you can see the different current level also. Here you can see that at 1000 watts per meter square current is 8.15, for 800 is 6.6 amps. Okay, so this IV and PV characteristics of the considered PV panel. And then this panel is connected, that means this panel is connected to the load. So this is going to be considered as load. That means here we are using resistive load, right? So this load is connected to the solar panel by means of a boost converter. Okay, in between load and the PV panel we are using boost converter. This boost converter going to be controlled by means of the PSO-Trained ANFIS MPPT. Okay, so it will be provide the duty cycle for that IGBT to control the converter in order to extract the maximum power from that solar PV panel. Okay, so here we are implementing that PSO-Trained ANFIS algorithm. Okay, so it receive the PV parameter, that means voltage. Okay, actual voltage of the PV panel. Okay, so and then this actual voltage of PV panel is compared with the PSO-Trained ANFIS model, right? Here I'm going to use that PSO file here, that means PSO-Trained ANFIS file. So already we used PSO.fs. So new trained value is PSO1.fs. Okay, so it received two input. So one is irradiation, another one is temperature. The output of that ANFIS will be PSO-Trained ANFIS will be equal to voltage at maximum power point, right? So it will be compared with the actual voltage and processed via PI controller. So it will generate a duty cycle. Okay, this duty cycle is processed via pendulum generator. Okay, so this pendulum generator will control this IGBT in order to extract the maximum power from that solar PV panel. Okay, so this is a Simulink model of the PSO-Trained ANFIS MPPT algorithm for solar PV system. So next you have to check the performance of the model. Okay, so here I'm going to simulate this model. That means initially I'm going to that means the solar panel receive two inputs. One is irradiation, right? Another one is temperature. So irradiation I'm going to kept at 1000 watts per meter square, and then temperature at 25 degrees Celsius. Okay, and then I'm going to change the load. Okay, and then check the response of power, voltage, and current of the PV panel as well as boost converter. Okay, so I'm going to simulate this one. So load will be added at every 0.3 second. Okay, so here you can see that the ANFIS MPPT start working here. So panel is at 1000 watts per meter square, 25 degrees Celsius. That means it need to provide maximum power around 250 watts. You can see here it will provide 250 watts. So after 0.3 second, right? Every 0.3 second load will be added in the system. So you can see that because of adding load, the solar panel is continuously supplying the power at the maximum point, right? So this is the power of the converter, boost converter. So this is current of the PV panel. Okay, and then this is current of the boost converter. So this is PV panel voltage, and this is voltage of the boost converter. That means load side load voltage is load current, and then it's load power. So output of the boost converter. Okay, so this condition, that means and load varying condition, the panel will be extract the maximum power because of that PSO-Trained ANFIS MPPT. Okay, so here you can see that it will extract the maximum power always. Okay, with the change in loading condition. Okay, so this change in voltage for that sudden change in load condition. So this is a change in current, PV current, with the sudden change in load condition. Okay, so next I'm going to test the same model for a change in radiation condition. Okay, so for that I'm going to fix the load here, right? I'm going to fix the load, and then I'm going to vary the irradiation here, right? You can see that I'm going to vary the irradiation every 0.2 second from 1800, 600, 400, and 200, and then I need to check the response of the system. So here the PV panel extracted to maximum power point because of that PSO-Trained ANFIS MPPT, and then after 0.2 second the irradiation changed to 800. You can see that here also the maximum power extracted. So at 800 watts per meter square, maximum power around 200 watts, and then here you can see that because of change in irradiation from 800 to 600, the maximum power, the for 600 watts per meter square, the maximum power is around 150. So here you can see that it will be extracted effectively, and then after changing irradiation from 600 to 400, so maximum power should be around 100 watts. You can see that here also the maximum power extracted. So after changing irradiation 400 to 200, the maximum power should be equal to 50 watts. So this here also you can see that the maximum power extracted from the PV panel by means of that PSO-Trained ANFIS MPPT. Okay, so this is a variation of uh, PV power, and this is variation of load power. So this is variation of PV current, and this is load current. So this is variation of PV voltage and variation of irradiation condition as well as the change in load condition. The system will be work fine. That means ANFIS, PSO-Trained ANFIS MPPT extract the maximum power from that PV panel in all irradiation condition. Okay, thanks for watching our videos, and also you can download this model from official website of this LMS solution or that YouTube channel. That mean so this official website for that LMS solution on the YouTube channel. So you can go to here, download MATLAB file. Okay, so in this section you can search that corresponding file by typing PSO trained, right? Okay, you will get that file here, right? So you can download the file from this website. And also another announcement, that means we are planning to conduct two workshops. So one is the wind energy powered EV charging station. It's a MATLAB online workshop. Okay, so this is planned on June 13 to 2020. So another workshop is planned on June 20 in the area of PID controller for a DC-DC converter. So this is also online MATLAB workshop. Okay, so if you are interested, you can register in this online workshop and participate. So thank you so much for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming video. Thank you so much.